So the last piece of the puzzle for structured task scope subclasses we're going to cover is going to be ShutdownOnFailure, and this is going to be the one that implements the invoke-all semantics. So unless we have an exception that occurs, then all of these things are going to run to completion. But if there is an exception, we will shut down on failure. So that's the way to look at this. You shut down on failure, whereas the previous version we looked at was shut down on success. So the first one that finished either successfully or not, we got that result. That was shut down on success. Shut down on failure says, let them all run, implement the invoke-all semantics, but if something does go awry, go ahead and shut down. And once again, you can get this code in the OpenJDK GitHub repository, and that's what we're going to walk through. So here we are in ShutdownOnFailure, which, as you can see, is a nested class in the context of structured task scope. We don't care about the return type here, so we just give it an object. There's only one VARHandle here for the first exception, because really all we care about in this context is, was there an exception or not? And we want to know the first exception. So we have a VARHandle for that. We set that down here in the static block. As you can see, we go ahead and get ourselves a little reflection handle hook, and then we go and look up in this class, finding the first exception, which is this field here, and we treat it as a throwable, which is what it is. So that's how this gets initialized first time in, before any objects are made. This is first exception, which is this volatile throwable. Volatile just means we can atomically set or get it, read and write it. The constructors, pretty much exactly as before for shutdown on success. We've got one that takes a thread factory. In the somewhat unlikely case, you want to create a platform thread for all this. Not sure why you'd want to do that, but you can. More commonly, you use the default constructor, which makes a virtual thread factory, so we get virtual threads here. And as before, here is the handleComplete method. And I guess I should really go over here and just show you this for completeness. So this is the run method. We switch back over to subtask-impl. Remember, subtask-impl is essentially the runnable, if you will, that's going to be run in a thread, in the thread flock, the flock of threads. And as you can see, run's going to be run in its own thread. It's going to go ahead and do the call, et cetera, et cetera, et cetera. And the last thing it does is it calls handleComplete. So this is the hook method that gets called back. And that's where we were down here in ShutdownOnFailure. We're in this hook method, handleComplete. And this implementation is super duper simple. So once again, ChatGPT is our friend because it generated all this nice documentation explaining what all this does. I sort of could ferret it out, but hey, let's use generative AI to make our lives easier. And so you can see what it does is it uses this compareAndSet operation, which is atomic, to ensure that only the first encountered exception is captured and stored. Much like we saw with shutdown on success, in that case, if it happened to be the first successful result, we wanted to poison everybody else and make them go away. In this case, only if something fails do we want to get rid of everybody else. So you can see here that if the subtask failed, so if its state is failure, and it's the first time in, the first exception, we haven't done any other exceptions yet, then in that particular case, what we're going to do is we're going to use this compareAndSet operation to say, if the first exception is still null, then grab the exception that is stashed away in that subtask and make that be the content of the first exception field. This is really, really cool. I'm going to tell you why it's so cool. So first of all, first exception in all caps is a VARHandle, so it can do this atomic check. The check it's doing is actually updating this field. So its first exception, all caps, is actually bound to the first exception field. And so when we do this set here, when we do this compareAndSet and we take the exception from subtask exception, if it's the case that first exception, the field, is still null, then we set it to that exception. What's interesting about this is, why does it do this check to see if first exception is null, followed by this compareAndSet? And the reason for doing this is because it will speed up performance considerably on certain kinds of processors, especially multi-core processors. So this check here doesn't actually go out and do anything with cache lines or or other things that are invisible to us as programmers but are happening under the hood. Whereas compareAndSet will actually do something that will affect the cache. So if we know that first exception is null, then that's a hint that we should do this call. After the first time in, first exception will not be null. And so if we know it's not null, there's no sense in doing this call. Why do we do this twice? Because between the point where first exception equal null is checked and where we actually do the compareAndSet call, there's actually a small window in time when this could change its value. Now, this is the thing that makes concurrent programming so complicated. You've all heard the expression, a person who does the same thing over and over again and expects to get different results is insane, right? The definition of insanity is doing the same thing over and over again and expecting to get, and being surprised when you get different results. Those people have not tried to debug concurrent programs. So when you try to debug your concurrent program, you do the same thing over and over again, and you get different results. And you're like, what the heck? So this is a very, very subtle issue. I just wanted to point it out because it's such a cool thing. And what we're doing here is if all these checks succeed, then we poison the well and we shut all the other threads down. Just to wrap up real quick, here's join. Does exactly as before. The other thing that I want to mention is throwIfFailed. So usually you call join, which will then wait for everything to finish. And then you call throwIfFailed. And what throwIfFailed does is it says, was there an exception? So you can see if the first exception was not null, in other words, there was an exception, then we're going to throw that exception. So that's just what you're supposed to do. And if you fail to do that, then you've kind of missed the point of using this mechanism, because the whole point is to be able to learn what went wrong. It's kind of like not checking a return value from a method. Probably one of the little quirks of Java structured concurrency is the fact that you need to remember to call throwIfFailed. And if you don't do it, then errors will be suppressed in ways that you don't really want to have suppressed. So that's the walkthrough of shutdown on failure.